Okun's law and the modified Phillips curve are empirical descriptions of how aggregate supply behaves over the business cycle, given long-term potential growth. Next, we turn to the demand side. We'll keep things simple here and focus only on inflation. In principle, it would not be hard to add other determinants of the demand side here as well, but since we are interested in money as a driver of inflation, we will focus on that alone. Now keep in mind that our simplified aggregate demand relationship links real output and levels to the real money supply, the level of government expenditure and taxation, here illustrated by a simple generic function y. Since we're interested in money here, because the money supply is constantly growing since we have shifted to fiat systems in the 70s, we will simplify this relationship a little bit, ignoring G and T. Now, to illustrate a little bit what I mean, the graph has growth in the money supply since the 1970s in the United States as defined by M1. M1 is deposits and currency in circulation. Now it's evident that the money supply has expanded constantly since the 70s in any given year, and that growth has accelerated after 2008. That's when the Fed first entered in this process called quantitative easing, that is buying assets at large scale, usually long-term treasury bonds. You can even see the latest monetary measures that are COVID-19 related here at the very end. You can see that in recent weeks, the money supply has jumped up dramatically. You may have heard that the Fed is now buying assets faster than it did after 2008, and this is where it shows up. Now, since money is not anchored to anything real, unlike, say, government expenditure or taxes, which ultimately depend on output, they depend on income, we often think of the main source of inflation as money, that is at least sustained inflation. That's the main reason why we reduce the scope here a little bit when we discuss aggregate demand. Reducing aggregate demand to a function of the money supply only yields a simpler function of output as a function of simply money and prices. Here, for simplicity, we'll assume the relationship is linear with an intercept of 0. So yt is simply equal to gamma times mt divided by pt. This is a little bit simplifying, obviously, certainly too simply empirically, but it serves keeping the algebra manageable in the following discussion. Now, assuming that the slope coefficient gamma is constant over time and positive, what affects the percentage change in demand for production, that is growth in yt, the left-hand side here? Intuitively, this should be straightforward, basic math. A percentage change in the money supply, that is money growth of, say, 2%, will increase output by the same proportion, that is 2%. Meanwhile, an increase in prices of 2%, i.e. 2% inflation, would decrease output by 2%. And that simply follows from a linearity assumption. What's the intuition here? Keep in mind that increasing the money supply should lower interest rates that should stimulate demand, whereas increasing prices increase money demand that tends to push up interest rates, and that would dampen demand. Hence, we assume that gamma is positive. Growth in expenditure on output is then equal to money growth minus inflation, or real money growth. GYT is equal to GMT minus PT. Growth in output, money growth, inflation. Money growth stimulates demand, driving GDP growth. Inflation has the opposite effect. Keep in mind that again, this rests on the assumption that money growth has in fact a stimulating effect. The faster pace of money growth that we've seen in the last 8 years, despite slower economic growth, is an indication that this relationship has weakened, and this is related to our earlier discussion of the lower zero bound and the liquidity trap.